So in this video we're going to talk about the power of a power rule, and we're also going to talk about the power of a product rule and power of a quotient rule. The power of a power rule says that when we raise a power to another power, we can actually multiply the exponents here. So on the other rules we just did, when we had the multiplying and dividing of powers rules, we could add the exponents when they are multiplied together. We could subtract the exponents when we're dividing, but here we have a power and in brackets raised to another power. So what does this mean? This means 2 to the power of 4, which is 2 times 2 times 2 times 2, and now we're going to raise that to the power of 3, which is 2 multiplied by itself 4 times, and we do that 3 separate times. So essentially we're multiplying 2 by itself 12 times. The trick is, or the rule says, I can just multiply 4 times 3 to get 12, and I can skip out all of this. So over here, 2 to the power of 4 all raised to the power of 3. Powers are side by side. I can multiply those together to get 2. 4 times 3, which is 12. And I could leave it in exponential form, or if I choose to, or if I need to, I can put in standard form of 4096. Another way of looking at this, if I wanted to go just to standard form, I could say 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. And then I cube that, which is 16 times 16 times 16, which is 4096 again. All these answers will give me 4096, and it depends on what I need. If I want standard form, this one seems to be the easiest. If I want exponential form, this one seems to be the easiest. And if I want to see how it looks conceptually, this one is the proper way. So we'll take a look at another couple examples. This one's called the power of a product rule. Again, power of a power rule is a power, and the power is raised to another exponent. Power of a product rule, or power of a quotient rule, is another name for when you're dividing. But power of a product rule is we have a product of two numbers, and then we're going to raise it to an exponent. So the rule says essentially I can distribute that 3 into the brackets as done here. So this way shows you why it works. 2 times 5, we'll do brackets first, we get 10. We cube it, which means 10 times 10 times 10, which is 1,000. Or the rule states I could take this 3 and I could distribute into the 2. I could distribute this 3 into the bracket to the 5, and again only when you're multiplying here. This is the power of a product rule. This is not when you're adding or subtracting inside the bracket. It is only when you are multiplying or dividing. This rule does not apply for adding and subtracting. So the rule again, when I'm multiplying or dividing, I can take the exponent outside the bracket and distribute it in. So now I get 2 to the power of 3 times 5 to the power of 3. Now be careful, I am multiplying, but the bases are not the same. Remember, when I am multiplying and the bases are the same, I can add the exponents, but the bases have to be the same. In that situation where we're looking at, these bases are not the same. The only way to get the answer would be to put them in standard form. If they ask you to leave it in exponential form, this is your answer. If they want you to put it in standard form, you'll find out what 2 times 2 times 2 is, what 5 times 5 times 5 is, 125, and then multiply these together to get 1,000. And we have the same answer, solving it different ways. Another rule, which isn't, there's not a title here, but this is power of a product rule. power of a quotient rules when we're dividing. So we can do the same thing. 2 divided by 3 all squared really means 2/3 times 2/3, which is 9/4. So 2/3 times 2/3. Or we could distribute the 2 in to get 2 to the power of 2, and the 2 to the 3, which is 3 to the power of 2, and then standard form would be 2 squared, which is 4, and 3 squared, which is 9, and we get the same answer. So again, if they want you to leave it in exponential form, this is the way you'd have to leave it. If they want you to put it into standard form, you'd have to leave it this way. So either way, you'd get standard form. This way, you don't get exponential form, and this way is the only way to get exponential form. So it depends on what they're asking. So again, here's some examples. It says write as a power. So if it says write as a power, we can leave it in exponential form. If it asks to write in standard form, we would actually need the answer, but it doesn't. So this is a power raised to a power, so it's power of a power rule. The rule says, power of a power rule says, when we have a power raised to another power, we can multiply these together. So I'm going to get 4 times 3, which is 4 times 2, which is 3 to the power of 8. That's your answer as a power. Leave it in exponential form, and that question's done. The next one here, same principle. We have a power, -7 to the power of 3, all raised to the exponent of 7. This is a power of a power rule. So I get 3 times 2, which is 6. So -7 to the power of 6, leave it in exponential form. And then this one, negative, and the negative is on the outside, so we're going to leave it the whole way. This 5 and the 4 did not touch that negative at all. If that 4 was on the inside, it'd be a different question. But right now it's on the outside, so we're going to leave it alone. Power of a power rule, we multiply these together to get 2 to the power of 20. And those questions are done. And then a last set of questions here. It says evaluate. So usually when they say evaluate, they want standard form. So again, 2 ways of solving this. We could use it as figure out what's in brackets first. So -7 times 5, which is -35, and then we're going to square it to get -35 times -35, 1225. Or we can use the product rule. Okay, so we can say, well, we're going to distribute the power of a product rule in there. So we're going to get -7 to the power of 2 times 5 to the power of 2. Again, we're taking the 2 and distributing it in as a power. -7 times -7 is positive 49. 5 times 5 is 25. And we get 1225. Again, same answer, different way. Whatever you feel most comfortable doing when they ask you to evaluate. If they ask you to leave it as powers, or they ask you to leave it in exponential form, you would have to leave it this way. But because they say evaluate, you can put it in standard form. Next question. Negative is on the outside, so we don't touch the negative all the way down. 3 times 2 is 6, and we're going to square it. Again, the negative doesn't get touched by the 2, so we're not going -6 times -6. We're going -6 times 6, which is -36. Or the negative's on the outside, so we're not going to bother with it. We distribute the 2 in again. That's the power of a product rule. So we go 3 to the power of 2, 2 to the power of 2. And again, this negative is untouched because it's outside the bracket. So this is negative 3 times 3, which is 9, times 2 times 2, which is 4. So -9 times 4 is -36. And again, we get the same answer. And our last example, we have a power of a quotient rule. So the power is 3, and the quotient is 78 divided by 13. So we'll distribute 3 into the 78 and the 3 to the 13. We get 78 cubed divided by 13 cubed. 78 cubed is 474,552. 13 cubed, which is 13 times 13 times 13, is 2,197. And when we divide these two numbers, we get 216. Or we can look at it this way. We could just figure out what 78 divided by 13 is. It's 6. we still have to cube it. This looks like a 63, but this should actually be 6 to the power of 3, so that's a typo here. So this should say 6 to the power of 3, which is 6 times 6 times 6, which is 216. Again, sorry about this, but this is a typo. This should say 78 divided by 13 is 6 to the power of 3. So this 3 should be raised up there, and this means 6 times 6 times 6. This is not 63. Again, the answers are the same. You could do it as, leave it as a power, or because it says evaluate, you could leave it as standard form, whatever works for you.